title of this packet is Formulae of Ionic Compounds. In this packet, we will describe 3 characteristics of ions and learn how to write a chemical formula. An ionic bond involves the transfer of electrons. One ion gains electrons, while another loses electrons. Ions are characterized by the number of atoms, the magnitude of the charge, and the direction of the charge. Some ions are a single atom. These are called monoatomic ions. Sodium and fluorine are 2 examples of monoatomic ions. Other ions contain multiple atoms. These are called polyatomic ions. Silicate and thiosulfate are 2 examples of polyatomic ions. The magnitude of charge refers to how many electrons are involved in forming an ion. If a species becomes an ion by losing or gaining 1 electron, that ion will have a charge magnitude of 1. If 2 electrons are transferred, the charge magnitude is 2, and so on. The last characteristic we will explore in this packet is charge direction. There are 2 possible charge directions, positive and negative. The ion that loses an electron has a positive charge direction because after the transfer it has more protons than electrons. The ion that gains electrons has a negative charge direction because it has more electrons than protons. The total positive and negative ionic charges must cancel each other out so that the resulting compound has a neutral charge. Here is a table showing examples of cations. The name, symbol, type, charge magnitude, and charge direction are given. Here is another table, this one showing examples of anions. Again, the name, symbol, type, charge magnitude, and charge direction are given. So what is a chemical formula? A chemical formula tells us what ions are present and their relative abundance. Let's take a look at the information given in the chemical formula CaCl2. We know that the cation is calcium because its atomic symbol is written first. We know that the anion is chloride because its atomic symbol is written second. The subscripts tell us that calcium and chloride have a 1:2 ratio. This means that for every 1 calcium atom, there are 2 chlorine atoms. Note that when a subscript is 1, it is omitted from the chemical formula. Now we will list the steps to write a chemical formula, and then we will look at an example. The first step is to identify the charge direction and magnitude of both species. Then determine which one is the cation and which one is the anion. Not all ions will combine in a 1:1 ratio. For example, you could have 2 anions for every cation. To determine the bonding ratio, you must calculate the least common multiple of the charge magnitudes. The bond ratio is shown by subscripts. The subscript for the cation will be the least common multiple divided by the charge magnitude of the cation. The subscript for the anion is the least common multiple divided by the charge magnitude of the anion. The next step is to write the symbol of the cation followed by the subscript for the cation. Do not include the subscript if it is equal to 1. Finally, write the symbol of the anion followed by its subscript. If either ion is polyatomic and already ends in a subscript, put parentheses around the symbol before writing an additional subscript. Now let's look at an example. What is the chemical formula for calcium and borate? First we look up both species and discover that calcium is a positive monoatomic ion with a charge magnitude of 2. We also find out that borate is a negative polyatomic ion with a charge magnitude of 3. The least common multiple is 6 because it is the smallest multiple shared by both charge magnitudes, in this case 2 and 3. This means that the subscript for the cation is 6 divided by 2 equals 3, and the subscript for the anion is 6 divided by 3 equals 2. Therefore, the chemical formula is the atomic symbol for calcium followed by a subscript of 3. Then the polyatomic symbol of borate written in parentheses followed by a subscript of 2. Now see if you can determine the chemical formulas for the compounds listed on this slide.